Chuck. Welcome to section 5.2 part 2 video. In part 1 of this video we looked at computations involving future value, determining what the value, the total amount will be in some given number of years with a given percentage of return on the investment. What we're going to take a look at today is present value. Present value, as the name implies, looks at what the value of the investment is right now. Okay, so what we're going to look at today is present value. One of the things I do want to mention is that I'm going to start keeping track of attendance by, at some point in each video, mentioning an attendance code, and then later that day there will be a quick one-point quiz under attendance where all you have to do is type in the code, submit that, and that will indicate that you have listened to the video. The codes will not be written down, they will only be spoken. So please be sure you keep up with the videos. The attendance will be a timed thing. It will only be available on a given date, just like attending class is a timed thing, only available on a given date. Okay, with that said, let's look at present value. In the previous portion of the section 5.2 presentation, we looked at future value. The idea there is if you take some amount of money and you invest it, and you come back at a later point in time, what will the value of that investment be worth? And hopefully it will have grown. Okay? So because that's talking about something in the future, it's referred to as future value. Present value looks at how much you would need to invest right now. For example, let's say in 3 years you want to have a really nice vacation to celebrate graduating, and your grandparents have offered to put some money aside for you for a really nice vacation. You figure out that in the end, when it comes time for this vacation, you want perhaps, let's say, $4,000. And the question is, well, how much would need to be deposited right now in some type of a money market or in a mutual fund or wherever you agree to deposit the money? How much would you need to deposit right now so that 3 years from now it will have grown to be $4,000? Present value looks at what you need to have right now. If you recall, when you're talking about continuous compounding, the amount of money that you will have in the future is equal to some amount that you have right now times e to the rt, or as is used in this book, kt. R and k are interchangeable. This p sub 0 is your present value. This P of t is your future value. From now on, I'll just refer to present value as PV, just like I'm referring to future value as FV. To find the present value, what you need to do is to divide each side by e to the rt. These will then cancel, and what that will give you is that the present value is equal to the future value divided by e to the rt, which can be written as p of t e to the negative rt, or negative kt. Now you got to be really careful because this formula looks very similar to the future value formula, with the future value formula being the p of t equals p0 e to the rt. The only difference between the two formulas being this negative on the exponent. So be really careful when you get writing things down. It's easy to get them mixed up. Let's take a look at an example. Okay. Let's say that in 10 years, Sam will receive $250,000 in trust fund. So what's happened is someone, a grandparent, a parent, a relative, somebody or other, has put some money aside and put the condition on it that in the year 2030, Sam is to receive the total money in the trust fund. This is commonly done to set money aside for a period of time. For example, when a person, a grandchild, for example, would be anticipated to start college or some after high school training. Or it's also done in situations where a family has money that they want to distribute amongst family members, but let's say Sam is just 12 right now. Well, Sam doesn't need $250,000 dumped in his lap at this point. He wouldn't know what to do with that reasonably, so the person who has the money and is setting things up will say, okay, I'm going to set up a trust fund where, for example, in 10 years, Sam will receive $250,000. If this fund pays, let's say 3.25%, compounded continuously, what is the present value? Okay. Another way of phrasing this is, if Sam's grandparents want to set up a trust fund where in 10 years he will receive $250,000, how much do they need to invest today so that it will grow to $250,000 in 10 years? Well, this makes reference to the formula we just looked at because it is a one-time investment. We want to know how much is going to be invested right now so that in 10 years there will be $250,000 e to the negative 0.0325. Here's the investment rate times the number of years, 10. Plugging this into your calculator, you should come up with the value, and please do plug this into your calculator. Take the time to actually work this out to make sure it really is working for you. You don't want to get on a quiz or something and find out there for the first time, uh-oh, I don't know how to get this to work. You should wind up with $180,631.84. This means that if Sam's grandparents today start or set up a trust fund for him, where in 10 years there's going to be $250,000 for him, what they need to have today when they set the things up is $180,631.84. One of the things you need to be mindful of in reporting your answers is keep in mind you're dealing with money in this case. Keep in mind what makes sense logically. Okay? Which means that you don't want to report, for example, $180,631.83792445. Whoops. That doesn't make any sense, does it? We know that money only is reported to 1/100th of a unit. So make sure that when the calculator gives you these other answers back, you transform them to a form that makes sense. Okay. If we want to compute present value of a continuous income stream, okay, where the rate of investment is continuous, we can work backwards. For example, recall that we had the formula in the previous section. The amount of money at some point in time, that's future value, is going to be the rate at which the money is being invested divided by K, or R if you would, e to the K capital T being the number of years it's being invested, minus 1. Now, I'm going to make a slight change here. What we want to know is we want the balance. which I'll refer to as B. Okay. This is going to be a one-time deposit, which is very different from a situation where you're having money invested on a regular basis. We'll take a look at some examples of that a little bit later. Okay. This is going to be a one-term investment or a one-time investment, and it's going to be a continuous compounding of the income stream. Okay. So what we're going to do here is we're going to replace this, which is the future value, with P0 e to the RT. And recall, P0 is the initial balance. So we can rewrite this as our balance, e to the RT, or here I'll use K since the rest of the formula uses K, capital T, equals our revenue stream, K, times e to the KT minus 1. What we want to do in this situation, because we're going to compute the present value, we want to solve for B. Well, to solve for B, we can divide each side by e to the KT. Okay. And dividing by e to the KT can work like that. On the left side, it'll cancel, and we'll get our balance is equal to our revenue stream divided by our interest rate times e to the KT minus 1 over e to the KT, like that. Now, remember, talking algebra here for a minute, on this right-hand side, all I really did was to multiply by 1 over e to the KT. Okay. On the left-hand side here, I multiplied by 1 over e to the KT. So I've multiplied both sides by the fraction 1 over e to the KT. To get to the next step, all I'm doing is multiplying these two pieces together. Using some further algebra to clean things up a little bit here, we have our revenue stream over K times, we're going to have e to the K capital T over e to the K capital T minus 1 over e to the K capital T. Okay. Just taking that fraction here and breaking it up into its two constituent parts. We've talked about that earlier this semester. Then, going to do a little bit more algebra. And what we wind up with is our balance is equal to our revenue stream divided by K times this is just 1 minus, we could continue to write this term as 1 over e to the KT, or we can take advantage of the negative in the exponent and write it like that. This is how we're going to compute present value, okay, with an income stream and continuous compounding. Okay, so there's that. Hold on to this formula. This is one that's going to be important to you. And in fact, let's just go ahead at this point and jot down the formulas that we're going to need. Okay, so what's going to wind up being the case here is we're going to have a definition just like we had for future value. And in this case, the accumulated present value continuous income stream can be computed one of two ways. It can either be computed as B is equal to R of T over K times 1 minus e to the negative k t. Okay. This is only used when R of t, our income stream, is a constant. So for example, each year the plan is to invest $500. Okay. My wife's mom each year has contributed $250 to the kids' college fund. Okay. She's been doing that for a number of years, and that's been allowed to grow. And when it came time for Lauren to go to college this year, the neat thing was there was enough money in there for her to buy a computer and a few other things that she needed to get started. The point here being that each year Becky's mom put in a regular, constant amount of money, $250. That would be a scenario like this. Okay? The revenue stream is constant. Now, using it as an example doesn't mean that we would use present value to figure out what is going on down the road. That would actually be a future value problem, because the question is, well, gosh, at $250 a year, how much are the kids going to have at some point down the road? But a constant stream is what's being illustrated there. Second option is the balance, and remember, by balance we're talking present value, is equal to the integral from 0 to capital T R of t e to the negative k lowercase t dt. This is when the revenue stream is not constant. An example this would be, suppose that the plan is to put 3% of your salary each year. There, hopefully your salary is going to be going up, so the revenue stream isn't going to be constant. Now, something I want to caution you about here. When people write this integral down, I have seen quite a few people over the years put in capital T. The grade shaded exponent value is a variable. That is not the capital T, for example, 10 years. Okay. Something I'd like to point out here as well is it's fairly straightforward to see a relationship between the present value and the future value. Okay? The present value is p sub 0, and that's this integral 0 to capital T R of t e to the negative k lowercase t dt. Okay, that's our present value. The future value, okay, the amount of money at some point down the road, is equal to p sub 0 e to the rt. Now, the cool thing here is the formula for this future value is going to be e to the k capital T, the integral from 0 to capital T, R of t e to the negative k lowercase t dt. Notice there is a great deal of similarity between this and this. In fact, the whole integral is the same. The only difference is this e to the kt is a coefficient out front. Where did that come from? Well, what I would like you to notice here is that p sub 0 has this value. So if we take this and substitute it into this formula for P sub 0, P sub 0 is this piece, and the only thing left is the e to the RT right there. Okay, so realize that there truly is a relationship between present value and future value, and you can see it in that setup right there. Let's take a look at another example. This is example 4 in your book, and you can find example 4 in your book on page 486. So if you're following along with the book as you're watching the video, you'll find this on page 486. Okay, so we have a person, let's say you want to buy a frozen yogurt franchise. Okay, McDonald's is often a franchise. What's a franchise mean? Well, a franchise means that you pay the company, let's take McDonald's as an example, you pay them some money up front. And in exchange for this money that you pay them up front, they allow you to use their name, McDonald's. They provide you with some marketing analysis to determine where is a good location to establish your restaurant. And they provide you the opportunity to buy all of their products, their cups, their napkins, their wrappers, their hamburgers, their cheese, everything. And in fact, as a franchise, you are required to only use their materials. This ensures continuity or consistency from one store to another. If you go to a McDonald's in Boston, you'll get the exact same quarter pounder as if you went to a McDonald's in Austin, Texas, or Fairbanks, Alaska, or Honolulu, Hawaii. It'll be the same hamburger because McDonald's has very carefully controlled each product involved in going into that hamburger. Okay, consistency is what they're after, so that you know time after time exactly what you're going to get. There are no surprises. When you go to McDonald's, it doesn't matter where, you know what you're going to get. Okay, so looking at buying a frozen yogurt franchise, same idea as buying a McDonald's. Okay. What we need to know is we need the present value, the accumulated present value of an income stream over an 8-year period. The idea here is you want to get some idea of right now what they're charging you for this franchise. Okay, and they tell you that the franchise licensing fee is the present value of an 8-year projected income stream. And they give you some amount of money, and it's going to be a large amount of money for something as successful as a McDonald's. Let's say this is a very successful frozen yogurt franchise. Okay? The company estimates that your income stream is going to be $275,000 a year. Okay, and at $275,000 a year, what they're going to want to do for the present value is to say, all right, we're assuming that you're going to have an income stream of $275,000 a year. We're going to assume an investment rate of 3.3%, so that's kind of like they're charging you the interest up front. Okay, and the question is, how much do you need to pay right now for the licensing fee? You do some marketing analysis on your own, okay, and you come up with something other than $275,000 a year. Now, this present value, this accumulated present value, because this is the amount of money that's going to be accumulated over an 8-year period of time, and this is what you're paying for. This accumulated present value is very, very important. This is a part of the contract. This determines how much you're going to pay. The 3.3% is very important. That's going to influence how much you pay. Question is the company being trustworthy, or are they giving you an inflated present value? It may be they're just selling franchise license and they don't care if you make it or not. They don't care if you go out of business in 2 years because they've got their whatever the fee is that we'll compute in a minute, and they're on to the next person. Can this company be trusted? So the first thing we want to do here is, based on the projections that the company has provided, what is the present value? What is the future value based on this constant revenue stream? We'll call this stream 1, because in a little bit we're going to look at what your market analysis projects. So let's do solution with revenue stream 1. First thing we're going to do is we're going to look at what's the future value of this income stream. Okay? Well, the future value is going to be, because it's a constant, oh, that's right, okay, it's going to be whatever the revenue stream is divided by the interest rate times e to the k capital T minus 1. Now, just a reminder, you'll be given these formulas, okay, but you need to know which ones to use. The formula that does not involve the integral is the one for a constant income stream. In this case, we have a constant income stream. They are suggesting that you're going to be making $275,000 a year over this period of time. K, the interest rate, is going to be the 0.033. Remember to convert that back to a decimal. E to the K, so that's going to be the 0.033. And it's going to be times the 8-year period of time that they use to compute the franchise licensing fee. Okay, so remember, first off, this is the future value. When you compute this with your calculator, and be sure you can actually do this with your calculator, what this says is in 8 years' time, that income stream will have accumulated to be a total of about $2.5 million. So over 8 years' time, what we're looking at is a little over $2.5 million of total accumulated value. Now remember, this isn't all what goes in the bank, because you're going to have to live off of some of this. You're going to have to use it for other things as well. But what it's saying is if all the money that was brought in was accumulated, invested, this is what it would add up to. Okay, so we're looking at a potential of $2.5 million over the next 8 years. Second thing we want to do is compute the present value. With the present value, this is going to be how much money the franchise fee is going to cost you today. For the present value, if we want to determine what the balance is, well, that's going to be the income stream divided by K. And recall, that's the formula we just recently, in today's video, came up with. It's going to be this formula. Substituting in the values we have, 275,000 divided by the 0.033. Want to make sure I was thinking it was 32 there. Didn't want to mess things up. 1 minus e to the negative 0.033 times the amount of time. Okay, and you might want to pause the movie right now and quick figure out what this value is. Okay, this value is going to be the present value of the franchise licensing. Okay, essentially this works out to be $1,933,553.84. means is if you go and you buy the licensing or franchise fee for this particular frozen yogurt business, in the contract they're going to include a present value of the income stream at $1.9 million. In other words, up front, you've got to fork out $1.9 million for the privilege of being able to hang their sign out front and buy their materials, the frozen yogurt mix, the machines, They'll provide market analysis on a good location, but you've got to have $1.9 million to pay to the company. Now, this does not include the money for you to build the building or to buy anything from them. This is the permission to hang their sign out front and use some of their research. Okay, so you're thinking, man, that sounds a little high. I wonder if they're just taking me for a ride here. Okay, you coming up with $2 million essentially, or let's say $1.9 million, to buy a franchise. That doesn't include the building or anything. That's just the permission to hang the sign out front. $1.9 million, that's a lot of money. You got to make sure that this is really going to work. So you do some market analysis on your own, and your market analysis suggests that the revenue stream is going to look like 80,000 times the year. Now this is a whole lot different from $275,000, and at this point you might be wondering, oh gosh, is this company just taking me for a ride, going to take $1.9 million from me and say, so long, good luck? What this 80,000 T represents is, with any new business, you don't have a clientele and it takes time to build that up. So what this income stream allows for is a smaller income the first year. In fact, it's projecting $80,000 the first year. And it's going to be kind of tricky paying back a $2 million loan, making $80,000. Okay. But then the second year, it's going to be 2 times 80. The fifth year, it's going to be 5 times 80. And you can see the value of the income stream growing over time. But the question is, are the forecasts that they have provided reasonable or not? Well, as we did before, let's compute the present and the future value of this. We'll call this income stream 2. Okay. With the market analysis you have. Okay, so before we did the future value first, and the future value, what is the future value? Well, you may have to look that up, and if you have to, that's fine. The future value is going to be e to the k capital T, the integral 0 to capital T. You don't have to memorize these formulas, you just have to know how to use them. This is going to be our revenue stream. I put the sub 2 there because we're using a specific revenue stream in this computation. Be careful. This is intentionally a lowercase t. So what this is going to work out to be is we're going to have our E, our interest rate is 0.033 times the number of years is 8. We're going to do the integral from 0 to 8. Now this time we're going to change things a bit. It's going to be this 80,000 t e to the negative 0.033 lowercase t dt. Okay. If you want, you can bring this 80,000 out front. Either way, pause the movie, evaluate this on your calculator, and see what you get. Okay, hopefully you paused the movie and computed it on your calculator. You should come up with $2,000,000 $800,969.43. Now, this is what your market analysis is suggesting the accumulated 8-year income stream is likely to look like. Let's compare this to what the company suggested the 8-year accumulated value would be. You have $2.8 million. What they are telling you is probably $2.5 million. So are they inflating the numbers? Doesn't look like it. With that in mind, it looks like they're being on the up and up, but let's compute the present value. Remember, the present value is what they're asking you to pay now. Okay, so to get the present value, we need to go back up here in our definitions. Here we are. Okay, our present value is going to be this integral right here. Okay, so it's going to be the integral from 0 to capital T, our revenue stream that we're working with now, and it's going to be e to the negative kt dt. Now, something I want you to notice. You do not actually have to do a separate problem to get the present value. This integral right here, do you see it up there in the future value? It's this part of what you've already computed. When you are doing your future value, if you compute the value of that integral by itself, see it? That'll give you the present value. So each time you're doing the future value with a revenue stream that is not constant, the first thing you're going to do is you're going to compute the present value, the balance. Then what you're going to wind up doing is multiply it times e to the kt. Okay, so let's say you didn't jot that down. That's fine. I didn't jot it down up here because I wanted to point this out to you. So what this is going to wind up being is the integral 0 to 8. We're going to have our 80,000 times t e to the negative 0.033 lowercase t dt. Now, what you need to do here is to put the movie on pause and figure out what the present value is. Okay, hopefully I actually paused the movie to check and see what this computes to be. You should come up with something like $1,966,012.26. Okay, so this is what your market analysis suggests a fair purchase price is under the conditions of 8 years at 3.3%. Compare this to what the company's asking. What they're asking is 1.93. You're saying, gosh, it looks like it's worth 1.96. Does it look like the company is being fair with you? It looks like it. It looks like what they're doing is they're giving you estimates that are running slightly low. Okay, earlier in the video I mentioned that there would be an attendance code that would be requested on a quick one-question quiz, and that's just to verify attendance. Jot this number down. The attendance code is 3764, then the capital A. 3764 capital A. Okay, so when you get to the quiz and it says what was the attendance code, you type that in, no spaces, capital letters. Let's look at example 5. This is located on page 487. Okay. In this situation, we're going to look at a scenario that we talked about earlier. Some grandparents want to invest some money so that in 18 years there are two ways that this can be achieved. Okay. We can invest the money at 3.5%. They're doing a fairly conservative route here. You can invest the money at 3.5%, where either you do a lump sum, which means you walk in today, you write a check, and you say there, and the investment firm takes that money and works with it for 18 years. And when the child comes back 18 years later, there should be $100,000 or maybe more there. The second way to do this is to say, well, gosh, we don't have the lump sum amount to actually do this investment like that. How about if we make payments each month, or an investment each month into this account? And the question is, how much would you have to pay each month? Let's take a look at each way. First, we're going to do a lump sum. Now remember, the question is, how much money do you need right now? Well, since it's an amount of money for right now, that means it's going to be a present value problem. We're assuming continuous compounding. Okay? And what we can use for this is P of t equals P sub 0 e to the RT. Okay? Because we want to know how much money right now, that's this, the present value, or you can also refer to it as the balance that you need to deposit right now. And this could be set up pretty easily. The amount of money that you want to have in the future is $100,000. We don't know what the present amount is. E to the 0.035 times 18 years. The way I would suggest doing this is to first enter this into your calculator. Okay? And when you enter that into your calculator, you should wind up with 1.877 something or other. So what we really have is P sub 0 times this number. Well, to compute P sub 0, all you need to do is divide both sides by this 1.877. So we're going to have this 100,000 divided by the 1.8776. Now, I'm not going to divide or round off. And what this works out to be, if you carry all the digits of accuracy, is $53,259.18. So that says basically, if they wanted to set up the account today, write a check today, you would need to write a check for $53,260, rounding it off a little bit. And what that would do is it would allow for an account to grow to $100,000 or hopefully more in the 18 years that this grandchild's going to be growing up. Second way to do this is with an income stream. Okay. Let's say the grandparents say, well, gosh, we don't have that kind of money right now that we can just cut a check for $53,000. That's not going to happen. So what we want to do on this income stream is we want to determine R of t to achieve the $100,000. Okay, so we want to figure out how much money they would need to be putting aside to achieve the $100,000. This is going to involve an income stream where money is deposited each month, each year, each quarter, whatever they choose to do. This is going to use the formula. Let's go up here. Here we go. Okay. We're going to use, which formula, where is it? There we go. Okay, so, yeah, I'm not seeing it right now. It's not catching my eye. So This is going to use the formula where we set it up 100,000 is equal to R of t over k times e, and it's going to be e to the kt minus 1. Okay, so we're going to want our 100,000 equals this amount. Now, let's plug things in. Actually, I think I did zoom past it up here. Let's go up and find it. Yeah, here it is. Okay. Whoops, that's not the one. Where'd it go? Okay, anyway. It's somewhere there in the notes. I don't want to spend all the movie flitting through trying to find that. Here's the formula we're going to use. Okay. We want to know what the revenue stream is. We want the future value to be this amount. Oh, that's right, future value. So we've got to use future value equations here, don't we? Okay, so this is going to be the future value equation. We don't know what this revenue stream is, but we know what a bunch of the other stuff is. Equals, I'll just call this R. The interest rate, I believe, was 3.5%, so it's going to be the 0.035 times e to the kt, so that's going to be the 0.035 times, this time it's going to be 18 years, minus 1. Okay, and a great deal of this you can work out on the calculator. What we can do is we can rewrite this as R of t, and using our algebra, plug this into the calculator. Okay. When you substitute that into the calculator and then divide the 100,000 by it, what you're going to get is a revenue stream of $3,988.10 per year. So what this says is, if they want to still achieve this same $100,000 for the grandchild, you need to be investing basically $4,000 a year. That amount would work out to about $332.34 per month. So if the grandparents are there, whoa, I don't know if we can just cut a check for $4,000 a year, that might be hard to come up with. A second option is to just go ahead and do a payment each month. Alright, in the next example, example 6, which is found on page 488. Let's try changing that. Okay. We're going to look at a situation where partway through a contract, the organization decides to buy the person out. And we're going to look at, well, how do they figure out an amount that's fair or agreeable to both sides to be bought out? And then being bought out, remember, you're giving the person a given amount of money in exchange for the cancellation of the contract for whatever period of time remains on the contract. Okay, so let's say that you have a baseball player. This baseball contract, and the contract is for $3 million a year for 5 years. Okay, after the second year, so the player has provided 2 years of service to the team. After the second year, the team decides, the GM or whoever decides that they don't need this person's services anymore, but they have signed a 5-year contract agreeing to pay them $3 million a year, and included in this contract would also be a percentage rate where it deals with early buyouts. So at the point where the player agrees to play for the team, this stuff is all laid out in the contract, that if you get injured or for whatever reason your game goes bad and we want to get rid of you, we will pay you up front a lump sum at, for example, 2.8% a month. Okay, in this case, the first thing to determine is the revenue stream a constant or is it a variable income stream? Well, you take a look here, $3 million a year, that is a constant. Each year the player gets a check for $3 million. Okay. After taxes and fees to the agent and things like that who help negotiate. Okay, so after the second year, we're looking at a buyout. So we're looking at a buyout after 2 years. The person has provided 2 years of service. What we're concerned about is the accumulated future value after the second year. So we're looking for what is the value of years 3, 4, and 5. First thing we're going to do is we're going to look at the accumulated value of the first 2 years' pay. Regardless what the person did with this money, whether they blew it all or invested it or whatever they did with it, we want to look at the future value, okay, of this first 2 years' money. Now remember, what we're ultimately working toward is how much should the company pay right now. So ultimately this is a present value problem. But in getting a present value, part of what we have to look at is what is the overall value of the contract? What is the overall value of the money that's already been paid? So the accumulated future value from the first 2 years, because it's a constant rate of revenue, is going to be the 3 million divided by the 0.028. Be careful to choose the correct equation. This is going to be the 0.028 minus 1. I'm going to leave the computations to you. Go ahead and actually do those. Okay, hopefully you actually paused the movie and did that. If you didn't, you need to practice this stuff, because when you get on the quiz and test and things, well, make sure it's working great for you. Okay, so what this says is that the accumulated value of what the player has already been paid is $6.2 million. Then what we're going to do is we're going to look at the accumulated value of the entire contract. We're going to compare what the entire contract is worth to what they've already been paid, taking into consideration that this is how much it will have been total at the end of the 5 years. Bet you didn't think the baseball involved calculus, just to try and get players out there on the field. So we're going to have the, what did I do? 2.8, this is going to be times 2. This is going to be 0.028 times 5, the total 5-year value. So with this 2 here, this is what the first 2 years of the contract are worth. With the 5 here, this is what the total contract is worth. And when you work this out, once again, put the movie on pause and actually crunch this out. When you work it out, you wind up with 16 million. There. And as always, rounding things off to the nearest penny. Now, what the last 3 years are going to be worth Okay, the last 3 years of the contract are going to be whatever the amount was for the total contract minus the amount that the player's already been paid. So to get that, you're going to take this $16,100,764.16, subtract from that the $6,171,180.40 the player's already received, and we get that the last 3 years of the contract down the road are going to be worth $9,929,583.76. Okay, so the last 3 years needs to grow to this. What we want to do is we want to compute a present value for this amount. Okay? And remember, this is what it will grow to in 3 years. So what we're going to do is we're going to say, okay, the amount that we want in the future is equal to some amount that's going to be paid now, e to the RT. The future amount is going to be this $9,929,583.76. The present amount, we don't know, E, and it's going to be raised to whatever the interest rate on this one is, 2.8%, 0.028, and because there are 3 years remaining on the contract, we're going to use 3 there. Okay, so we get P sub 0, which is the balance, which is the present value. When you do this 9.9 million and you're going to divide it by this, first get that value on the calculator. Go ahead and do that first. Then you divide the 9.9 million by that value, and what you get is $9,129,569.67. This is the present buyout value of the last 3 years. Okay, so what winds up being the case is if the team manager, owner, whomever decides that this player needs to move on for whatever reason, they can buy out the last 3 years of the contract, and they have to work with the agreed upon percentage rate. If the agreed upon percentage rate in the contract is 2.8%, to buy them out, to give them their walking papers today, you got to cut them a check for $9.1 million. Wow. Okay, let's take a look at one more example here. Okay, this is an example that would more likely come into play for a lot of us, or something that we're more likely to be able to relate to. Let's say that you're looking at buying an established business. Now, an established business might be a little coffee shop, a donut shop, a shoe store, whatever it is you might be interested in selling. Okay? When you're buying an established business, part of what you pay for is a predetermined, agreed upon number of years of income. Okay, so you wind up in buying the place, you add up, well, what's the value of the property, what's the value of the building, what's the value of the inventory we're going to get, plus you also have to pay for several years of projected income, because it took that person years to build up that clientele, and when you come in, the clientele's already there, and that's worth something. So let's say you're looking at buying an established business. Okay, and with this established business, has right now a $450,000 a year profit. Okay, so what we're going to do is look at how would you compute the present value of this if the contract reads that you're going to buy 6 years worth of the profit at 3%. So to go about solving this problem, we first need to figure out what is the accumulated profit for 6 years. So the accumulated profit for the 6 years is going to be the $450,000 per year. Remember, in this case, we have a constant revenue stream divided by the interest rate, so we have 0.03 times, here we're going to use the formula e to the 0.03 times 6 minus 1. Crank that out. Now remember, this is the future value. Okay. So we first have to do in figuring out present values, figure out how much it's going to be worth in the future, or the total worth of all of it put together. The total value for this $450,000 a year income stream is $2,958,260.45. Now, to get the present value of that, and the reason we want the present value is you are today, for example, going to sign a contract that says, I will today pay you this much money for the projected income over the next 6 years. And that projected income is paid in today's dollars, not what it's going to add up to over the 6 years. Okay, so what we wind up doing here is P sub 0, the balance right now, P sub 0 is going to be the amount that we just computed. Okay, it's going to be this amount times, now be careful, we're going to wind up using the P of t equals P sub 0 e to the RT. So what we're going to do is we're going to divide by this e to the RT. Remember, we talked about this earlier. And our P sub 0 is going to be the amount that we have in the future. Okay, and that future amount is what we computed there, times e raised to the negative 0.03 times 6. Negative because we're dividing by that amount. When we compute this on the calculator, and I would suggest as always to do the e first, multiply the 2.958 million times that. What that gives you then is a present value of $2,740,946.83. So in the contract to purchase this property would include the value of the property, the value of the building, the value of any on-hand stock that is in the store, plus paying for the present value of the accumulated profit over the next 6 years. Okay, with these problems, you always have to figure out first, what will it accumulate to be total? You have to get the total value. That's a future value. Then once you have the future value, you know what your goal is. The goal is to, over 6 years, account for this much money. So over 6 years, we want to account for that much money. To account for that much over 6 years, need to pay this much now. Okay, several things I want to make note of for you. Okay, that's the end of that one. Okay, homework will be posted. Okay, the The homework will be in the My Math Lab, so make sure you get to the My Lab homework. And it will deal with both future value and present value. I'm also going to put up some extra practice problems for present value. Now, these practice problems for present value will be posted on this page where you found this movie. Okay? Just like the problems for future value were posted below the movie and the notes, so too these practice problems that I'm referring to here will be on this same page below the movie and the notes. Those will be posted a little bit later. Friday. We're talking about Friday, April 3rd. There will be a quiz. This quiz will cover section 5.1 and 5.2. Now there's a considerable amount of material between these two sections. Okay? Remember, 5.1 talks about consumer and producer surplus. We talked about how to derive those equations, how to compute producer-consumer surplus. We looked at price ceilings and price floors. In section 5.2, we've looked at both future and present value. Okay. The quiz is going to be set up in such a way that it will post during class time. You'll have access to it, for example, for perhaps half an hour, and then it'll pull off. Won't be available after that time. You can go ahead and print off a copy of it or copy it by hand, whichever is more convenient for you based on what you have available to you to work with. Work the problem. You'll have about a half an hour to work the problem. At the end of that half hour's time, you're going to need to submit your answers. Now, to submit your answers so that we can include partial credit and I can see your work, what I want you to do is to take a picture of it and email it to me. Take a picture of your final work, email it to me, and that will be the submission of your quiz. On grading these quizzes, I'm not going to be able to return the individual quizzes to you, but I will make notes on how each quiz was graded so that if you have specific questions, I will have some notes that I can go back to. But trying to email everything back to everybody gets to be a huge amount of work, and I'm concerned about being able to get it done and keep up with class. I will post solutions, so what you will want to do is you will want to keep your original copy of the quiz. That'll be your quiz that shows the work that you'll use to study for tests and to study for final exams. Keep your original copy. You can compare that to the solutions that will be posted, just like we've been posting quiz solutions all along. But be careful, because that quiz will post on Friday, April 3rd, during normal class time. It will post for about a half an hour. It'll be available for about a half an hour, at which time it'll then disappear. And at the end of the half hour, you will need to email me a copy of your work. Take a picture of it, email it to me, and that's what I will grade. If you have any questions, I'm going to type up more carefully a description of what goes on with the quiz details. But be sure that you are available on Friday during normal class time. I'm assuming that time's available because you would have been there anyway had we been in class. So you've already got that period of time blocked out in your schedule. Keep it blocked out for the rest of the semester, because we will be making access to that time, whether in the 1220 or the 125 section. Hey, I wish you the very best with these problems. Remember, the Math Lab is still available. I'm going to get things set up on WebEx so that we can have office hours via WebEx if you need help. Take care. I hope you have a good day. Bye-bye.